Good day. We are looking at PowerPoint about electron configurations. In previous years, you would have called it electron arrangements, and we'd only ask you to draw electron arrangements up to about calcium. This year, you are going to learn how to deal with basically any element and figure out its electron arrangement, which we now call configuration. Electron arrangement is hugely important to an element because it determines whether it's reactive or not and how it will react. And we want to get good at coming up with electron configurations, and that means figuring out how electrons will fill the orbitals that surround the nucleus of an atom. Now, electrons fill in the lowest energy orbitals first, and those happen to be closest to the nucleus. And so as we go and get to bigger and bigger atoms, the electrons will fill orbitals that are farther from the nucleus, and therefore those atoms tend to be bigger. This is a chart that's in your textbook. It's not one you memorize, and we actually have an easier way of dealing with it, but what it's saying is we have S and P and D and F orbitals, and these will have different shapes and sizes. So a 1 is going to be smaller than a 2, 2 is smaller than a 3, 4, 5, 6. As we go up in numbers, it gets bigger. Now, turns out the s orbitals are spherical. Then when we get to p orbitals, we get to 3, and then when d, we have 5, and then 7. So it goes 1, 3, 5, 7 as we go from s, p, d, and f. So what this is saying is we'll fill the 1s first. Once it's filled, then we fill the 2s, then the 2p, then the 3s, then the 3p, then the 4s, and now the 3d, because it's lower, then the 4p. It's hard to remember that, but basically it's almost like pouring water into a glass. And what is the water going to hit first? Well, we have an easier way to remember the order of filling, and that's going to come from a chart. Before we get there, orbitals are the area around nucleus where we're most likely to find the electron, and we're not going to find the electron nucleus. So you used to call these things shells, but we have orbitals and we have suborbitals. Every orbital has a specific size and shape, and when we put electrons into the structure of an atom, we have to be able to give it an address, and that address gives us clues about where it tends to be located. Now these things are zipping around rapidly, but it gives some clues about its position and motion. The wacky world of quantum. We're not going to get that exotic in this course. We're just going to get good at drawing electron configurations for atoms and ions. Now each orbital, so each of those little circles you saw in that earlier diagram, can house up to 2 electrons. But anytime you have 2 electrons in the same orbital, they have to have opposite spins. They have to be spinning the opposite direction. So s orbitals, we said, hey, 1 subshell, max 2 electrons. Then we have the 3, so we can get 6 electrons in those. The d is 5, 5 times 2 is 10. And the f's 7, so 7 times 2 is 14. So that means how many electrons total will fit into those kind of orbitals. So you're going to get a sheet showing you the orbital blocks, and that's going to be helping you figure out what you do. First thing in the question is you got to figure out how many electrons you are finding a home for. Then you're going to fill in from left to right, and once a row is complete, you move down to the next row. The usual thing, the instructions may look confusing. Once we do some examples, it'll be a lot easier. So, the smallest orbitals in this case are up high, and what this is saying is if I have 2 electrons, they're going to fill the 1s. If I have more than 2 electrons to find a home for, well, the first row is done, so then I go to the 2s. Let's say I have more than 4, so 2 went there, 2 went there. Next thing is the 2p, and I go until I finish filling that orbital in that row. Then the 3s, 3p, 4s, 3d, 4p, and usually we're not going to take you all the way down here. you can see where these things would be slotting in. The 58 would come after the 57, and the 90 would come after the 89 if we got down that far. So, fill that first row. Once it's full, go to the next row. After that row is filled, go to this row. And so on. So let's try an example. Now you say, what on earth is this? Well, I put the cart ahead of the horse. I've given you an electron configuration, and it's going 1s2, 2s2, 2p6, 3s2, 3p4. Well, the 1s and the 2s and 2p and the 3s and the 3p, these things are all these orbitals. Boom, boom, boom. Then you say, what are these numbers that are superscripted? So the 2 says there's 2 electrons in a 1s orbital. This 2 electrons in the 2s orbital. 6 electrons in the 2p, 2 electrons in the 3s, 4 electrons in the 3p. So I can add these together. 2, 4, 10, 12, 16. So if this is an atom, I'm finding a home for 16 electrons. So we have regular numbers, letters, identify orbitals. I superscripted superscripts to tell you that's the number of electrons. And when you add up all the superscripted numbers, that's your total number of electrons. And if there's an atom, it would have to be sulfur. So for nitrogen, well, I'm going to backtrack a bit. Boom, boom, boom. There we are. So here's nitrogen living right here. I fill the 1s, 2 electrons, so I go 1s2. I fill the 2s orbital, 2s2, so I go 1s2, 2s2. Then I'm in the 2p, so I go 2p, and I go 1, 2, 3. That's going to be its configuration. That's going to show up here. Boom, boom, boom. And 2 and 2 and 3 is 7. So that is the proper configuration for nitrogen. Now, if I cared about valence electrons, in the past you might have called them outer electrons. It's the outermost s and p electrons. So nitrogen has 2 plus 3, it has 5 valence electrons. And not surprisingly, nitrogen's in group 5, or 15 according to the slimy textbook. So that's what we're up to so far. These are configurations, and what we're going to be also showing you are some orbital diagrams. Oh, we have another example. Well, chlorine has 17 electrons, but a chloride ion has 18 because it's Cl1 minus. So we fill row by row until we get to 18, and we fill the 1s with 2, fill the 2s with 2, fill the 2p6 with 2p with 6 electrons, 3s with 2, and the 3p with 6, and you add them all up, and you get 18. So hopefully that's looking pretty straightforward.